solving equations. And then it's really going to be up to you to tell me what you want me to do. And so I have here a well-used unit circle. And I'm only going to deal with questions that have exact values, right? So you're solving equations where the answer is 30 degrees or pi upon 6, right? If you have a question where the answer is a decimal, that's really going to be, you know, calculator. That's a different story. So let's start off with a very simple one, because I think starting at the beginning is helpful. Suppose they're starting off the wrong way there. I'm going to use theta for the angle because I want to use x and y for different reasons. So suppose I was giving you sine of theta equals √3 upon 2. And for all the questions I'm about to do, let's just restrict our answers right now to 0 to pi and 2 pi. Then if you want to find theta, you are basically going to use your unit circle. And the x coordinate of the unit circle is the value for the cosine of theta, and the y coordinate is going to be the sine of theta. And if you take the y and the x coordinates and divide them, that will get you the tan of theta. So that's a very common thing. So I am looking for a y coordinate equal to that guy. And so you just scan through the y coordinates and I found one. Let's say that the answers are meant to be in degrees, so 60 degrees. And that is definitely correct. That's one of the answers. But typically, aren't there always two answers? So somewhere else in that unit circle, there's another angle who also has a y coordinate equal to √3 upon 2. So what angle is the second one?
120.
120. Great. Good. Now, if the question had been in radians, I wouldn't have done anything different. I would just have said pi upon 3 and 2 pi upon 3, right? So if it's radians, it's radians. If it's degrees, it's degrees, right? The unit circle doesn't really care. Now, when you are doing trig, where this guy here is a multiple. So for instance, let's suppose I do the cosine of 3 theta, and let's make that guy √2 upon 2. I'll cover that guy up and I'll just say the thing underneath my finger has a cosine of √2 upon 2. So the angle underneath my finger is 3 theta. And 3 theta, right, √2 upon 2. So I'm looking for an x coordinate, right, equal to √2 upon 2. So I'm going to get 45 degrees. And I'm also going to get somewhere else. 45 degrees has an x coordinate of √2 upon 2. On my unit circle, where's the second answer going to live? What other? I agree. Do you see it there? 315. Now, 3 theta is that. So if you divide both sides by 3, we get one of my solutions. And if you take this guy and you divide him by 3, so that's 315. Let's try it again. 315 and you divide it by 3, you get the answer 105 degrees. Now, do you notice that these two answers are in the range 0 to 360? But they are not the only answers. When this is a multiple, right? If it's 2 theta, 4 theta, 3 theta, right? A half theta, right? If it's a multiple, you need an extra piece of information because that is going to help you get the other answers. And it's the period of a cosine of 3 theta. Now you remember when you sketched it, wasn't the period? Well, can you tell me, what is the period of 3 theta?
Is it 2 pi over 3?
Well, it could be. If we do it as a degrees, it's 360 over 3, which is 120 degrees, which is what you just said in radians. Now you might say, well, how does this period help me find the other answers? Well, whatever answers you get, right, and I'm talking now about the final answers, not the numbers that you used directly from the unit circle, but what the theta at the end is. You will add 120 degrees to those guys, and that will get me my second answer. So I'm going to do a little table because I'm too near the bottom here, and I'll show you what our answers would look like. We got the answer 15 degrees. If I add 120 to it, I will get 135 degrees. If I add another 120 to that, I get 255 degrees. If I add another 120 to that, I get 375 degrees. But I'm going to not do that one because don't we stop at 360, right? So that one's too big. Now, if I do the second answer, we got 105 degrees, right? That was the second answer. So what do? You add the period. You add 120. That's 225 degrees. You add 120. You add 120. Don't bother, it's too big. That means that there were 6 solutions. Right, 6 different solutions to this one equation. Are we good with that? Right. Now,
so isn't that essentially just writing basically say 15 plus 360 over 3k?
Yeah, it is. And stopping when you get to a number that's too big.
Yeah.
Now, if you took that same, and you're right ahead of me, if you went and took that same equation, but you're being asked to write all the solutions, you would still have your 15 degrees, and you would still have your 105 degrees. And can you remember that plus 120k? Plus 120k. Remember the period k, right? And that would represent every solution in the universe. Now, if you do it in radians, you would get answers like, what is that? That's pi upon 12. So you get pi upon 12 plus 2/3 pi k. And this one would be, good grief, what is that? It's 990, it's 5/12 pi plus 2/3 pi k. So that's what the solution would look like if they wanted radians, and that would be all the solutions if you wanted degrees. The general version of that is the answer you got plus the period. Okay. So if you got an answer of 15 and the period is 120, 15 and 120. If the answer was pi upon 6 and the period was pi, it would be pi upon 6 plus pi k. Are we good with that? So let's just solve a couple of equations and I'll call that little bit done. I have some examples that I'm going to use from. That way I know the answer is going to come out relatively nice. Let's do, well, this is not 18, this is 18 from the textbook, but it's still okay. 2 sine the 2 theta is equal to 1. And we're going to be choosing only angles in the range 0 to 2 pi. So that means it's going to be radians, but they have to be between 0 and 2 pi. I use a technique that we use for all kinds of solving equations, and it has a little name called as long as you do it to both sides, it's okay rule. You know that rule? So I would divide both sides by 1. And once you get to the point where you are left with a sine of somebody, a cosine of somebody, or a single tan of somebody equals a fraction, as we have here, then this guy kicks in. So we are looking for, when is my angle equal to a half? So I'm looking for a guy who's, since it's a sine, I'm looking for a guy whose y coordinate is a half. And as I go through it, I see pi upon 6. I'm also looking for a second answer where the y coordinate is a half. Right, would you agree this guy has a y coordinate of a half? What angle also has a y coordinate of a half? In radians, which angle has a y coordinate of 1/2?
5 pi over 6.
Okay. Now I'm going to divide both sides by 2 to find what theta is. So that becomes pi upon 12. Divide both sides by 2, and that becomes 5/12 pi. Everybody's so far so good. Now, in this question, we're dealing with a 2 pi, a 2 theta, I should say. Won't the period be 2 pi divided by that constant? So in this case, won't the period be pi? Are you happy about the period of a sine of 2 theta ends up being a period of pi? So this is good answers. If I want the next one, I just add the period. And this guy gets me 13/12 pi. So that's a good answer. If I try to add another pi, right, another period of pi, that would be too big, right? So I'm stopped, right? I got everybody I need. If I take this one and I add the period, which is pi, I will get an angle of 17/12 pi. And that's a good answer. But if I try to add another pi, it would be too big. So in this question here, can you see there are going to be 4 distinct answers, right? 4 different angles in the range 0 to 2 pi, where this would equal a half. So far, so good?
Yeah, and if we
Yeah.
were to find all the solutions, would it be pi over 12 plus pi k and then 5 pi over 12 plus pi k again?
Yeah, pretty much exactly what you just said. So don't you kind of get 2 for the price of 1? You get all the solutions or only the solutions in the range 2 to pi. 0 to 2 pi, I should say. Is that clicking a bit better for some of you, right? Yeah, got 2 more of these guys, and I'm going to have to call it good. So let's do something with a tan in it, because tans are horrible. This is from the textbook, question 21. So I have the square root of 3, and the tangent of 3 theta is going to equal plus 1. Good grief, there's even more to that. Plus 1 equals 0. And they're only interested in the 0 to 2 pi, right? So first thing I would do is subtract 1 from both sides. And then do that. So the unit circle is going to help me find an angle. Who's that guy? That's the problem with tangents has always been that sines and cosines are easy, right? It's one of these two. Tangents are not easy because don't you have to divide one by the other, right? Y has to be divided. So I am looking for an angle whose y coordinate divided by its x coordinate ends up being negative 1 over root 3. So I'm looking for an angle where the y coordinate divided by the x coordinate is negative 1 over root 3. Now, if you're really good at doing that in your head, that's great. But the chances are that you're going to have to try one out, and if it works, great, and if it doesn't, you go looking for a different choice. So I'm going to go through these and tell you who not to pick. I'm
But
not going to
you
pick
taught us a
any of
neat
these.
trick.
Go for it.
Where you look at basically the x and y coordinate, but only the numerator. So it has to be 1 over 3. One of them has to be negative.
Right. So you want a y of 1 and an x of root 3. Agreed?
So like 5 pi over 6.
Well, let's find 5 pi over 6. A 1 over negative 3. Do you see the one she's pointing at? Okay. Now, I was going to say, don't look there, because aren't all of those positive? And don't look there, because aren't they going to give you positives as well? So you only need to look here and here. And the one that we got was cover the 2's up. Do you see the 1 over root 3? So that's 5, 6 pi. Where's the other one?
$11 pi over 6.
Check it out. See it? Negative 1 over root 3, which is 11, 6 pi, which is good. Now, be careful here. A couple of weird things are going to happen, but first let's get the period. When it's a sine and a cosine, isn't it 2 pi divided by the coefficient? But what is the period when you do a tan?
It's only pi.
Pi.
Yeah, so pi over 3. So put a little circle, whoops. So theta, divide both sides by 3, you get 5/18 pi, and divide this, you get 11/18 pi. So just finishing off the 2 good guys. Now, if I add pi upon 3, which is a bit messy, so since these are 18, why don't I just turn this into 6/18 pi? Won't I just make it easier to add them? So if you add 6 to that, you get 11/18 pi. That's kind of interesting. And if you add it to this fella, you get 17/18 pi. And if you add another one to them, you get 17/18 pi. And if you add it to this one, you get 23/18 pi. And I'm running short of paper here. Does anybody see anything interesting that is happening right now? Do you see anything on this side and that side that's kind of interesting?
We're coming up with the same answers.
Right. Have you noticed that all these answers are going to appear here? So can't we just ignore those ones and just keep adding till you get, well, until you get tired, right? So I would be adding on another 6. Then I'd add on another 6. Then I'd add on another 6, and thank goodness we've reached the end. So there'd be 1, 2, 3, 4, 5, 6 of them in that range.
Can you move your paper up, please?
Sure. So this side here is the only one I need to worry about, because this side here just ends up giving me the same guy later on anyway. And if you take these and keep adding on 1/3 of pi, boom, 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 you get 1, 2, 3, 4, 5, you get these 6 answers, and we are finished. If you wanted to do the general one, wouldn't you just take your first answer and add the period k? So, oops, on the wrong place. And add the period k. And wouldn't that be all of the solutions? Right, one answer plus multiples. The multiple is the period times k.
When we're
Yes.
finding the periods, is it just the 2 pi over the multiple of theta? So
If it's sines
right?
and cosines, yeah. And if it's tangent, it's just pi over the multiple of theta. So when it's a sine of 3 theta, cosine of 10 theta, it's 2 pi divided by the coefficient, in this case 3. If it's a tangent, it's going to be a single pi divided by 3. It was a good one. Let's look at one last example. And I'm picking a really horrible one to finish. And it should be a nice answer because I got it from textbook. It's question 9. But to solve it, you need to know some double angle formulas that hopefully you've got a good list of. This fella here can't really be solved while you leave this thing as a 2 theta, because these two do not play well together, right? Everybody should be the same, right? Now, if you go looking up what are called the double angle formulas, you're going to find that there are 3 versions of the cosine of 2 theta. Strangely enough, there's only one version for the sine of 2 theta. But there are 3 versions for the cosine of 2 theta. And only one of them is going to work in this equation. But let's see if we can find the 3 of them. Does anybody know any one of the 3 versions for the cosine of 2 theta?
1 minus 2 sine squared theta.
2 more to go. Anybody got one of the others?
Got
Cosine
2 cosine squared theta minus 1.
And there's one other one, which is probably the least likely of the 3 ever to be used, but it's here, so let's do it. What is the third version?
Cosine squared theta minus sine squared theta.
Now, one of these, and only one of these, plays well with this particular question. Should I use 1 minus 2 sine squared theta? Should I use 2 cos squared theta minus 1? And just don't think about that one at all, right? So either the first or the second one. Which one plays well with this equation?
The first one.
Agreed. Why?
Because
Why
it
did you
turns
pick?
sine.
Say, I didn't catch that. Say again, please.
Because it turns everything into sines.
Yes. When you've got an equation, isn't it just easier if everybody's the same thing? Oops. So everybody is a sine or everybody is a cosine. Well, let's start solving this equation. As long as you do it to both sides, it's okay, Ro. Tell me what to do to both sides here.
You subtract 1 from both sides?
I would do that. Not the only way to do it, but I would do it that way. Now, I do not like negatives. They're just a pain in the butt and they make mistakes. So I'm going to multiply both sides by -1, which essentially does that. Are you okay with that? And when you agree, that's just easy to work with. Okay, now look at the left-hand side. Can you see a common factor that we can pull out?
Sine theta.
I hear a sound there. I hope you can hear me over the thing. That's my dog telling me that a leaf has just fallen on the deck, probably. Or somebody walked by my house. We got this guy. Now, if you can factor two things and they equal 0, you can then say that the sine of theta is 0, or that 2 sine theta plus 3 equals 0, right? That's basically taking factors and finding what's called their zeros. Now, this guy is good to go. Oh, let's assume that we're interested in the answer from 0 to 2 pi again, right? So this guy is good to go. I'm looking for a y coordinate of 0. So I get 0 degrees, 0 radians, pi radians, and 2 pi. Now this fella, if you subtract 3 from both sides, and then you divide by 2, you get that. But this one, I'm going to say, generates no solutions. Why is sine of theta equal -3/2 never going to happen? What do you know about a sine? What does it, if I do a sketch thing? That's what a sine looks like, right? What do you know about the value of a sine function?
Never goes below 1.
Or -1, right? So isn't it impossible to get a sine of equal that? If you tried that on your calculator, it would just spew out error. So you would know it was impossible. So guess what? We've solved it. There are 3 solutions. Finished. Right. That's kind of what I've just picked up, looking at people's online tests and so on. But now we're at that kind of part where really it's your job. So what do you want me to go over? What topic? What ideas? Whatever. Nothing? I don't think nothing, unless you're really, really on top of it and everything is fine. And remember, you're not just doing it for yourself. If you've got a question or a homework or an idea that's a bit fake, a bit, you're not sure what's going on, I bet you there's lots of people in the same place.
I had a hard time with half angle formulas.
Okay. Okay, first thing, see if I can get this for you, because there's a lot of angle formula in the world, right? And we need to kind of have them. There are 3 half angle formulas. If it's the one I'm thinking about, it's the one that looks like these 3. And is that the kind of questions that you're talking about?
Yeah.
Okay, good. Now, I'm definitely not going to make up questions like that, because if I try to make up a question, oh, sorry, someone's at the door, be back in a moment.
Is anybody going to the basketball game tonight? You should. It's free if you guys have your IDs.
I'm not really one for basketball, but I do have a lot of homework for math, so or at least studying to do.
I don't even have an ID.
You play on the team, or are you just trying to get us to go?
No, I don't play. I'm just bored. Trying to find conversation.
Well, I apologize. One of the disadvantages of working from home is that people knock on your door sometimes, and since I'm the only one here, I kind of have to do it. So I do apologize for that. I'm trying to find a half angle formula, so that's why my hesitating is taking so long. I'm also going to try and find, if I possibly can, some questions that come out nice. So that'll just take me a few moments. Should be under trig, which we are. Open that up. And here we go. I'll just see if I can make this a little bit bigger for you. Plus, plus, plus. Okay. And now I've gone and lost everybody. Just brilliant. Where are you guys? I have lost everyone. Okay, sorry about that. I am trying to juggle 5 windows right now and none of them are behaving. So I'm not going to switch a window. I'm just going to write down what the formula are. I'm trying to do it for you. So the sine of a half theta is plus or minus the square root of 1 take away the cosine of theta divided by 2. The cosine of a half angle is also plus or minus 1 add, I should say, cosine of theta over 2. And the tan of a half angle can be found by doing the sine of theta over 1 plus the cosine of theta. And the most common type of question that you get using the half angle formula, and I'm not even sure you can see what I'm writing. Can you now see what I'm writing? Yeah, okay, I'm down to 4 windows now, so that's enough windows for me to keep open. Right, so you typically get questions where you're being asked to find the exact value of an angle using these fellas, right? So suppose I went and said to you, what could I use? Oh, look for a question, that's a good idea. Suppose I wanted to know the cosine of 22.5 degrees, and I wanted, and the key here is exact value. Because if I wanted to know that as a decimal, wouldn't I just plug into my calculator and get nothing 0.1234? So we want an exact value. So what you have to figure out is who theta is. So what angle does theta have to be so that a half of it gets you 22.5? The way my brain works is, wouldn't it be a half of 45 degrees? Does that make sense? If you just double that, you get the missing theta. So if it's 17.5, double it. If it's 45, double it, and so on. So that's the first part. Now, when I look at the cosine formula, do you see how there's a plus or minus square root thing going on here? Great.
Yeah.
Now, one of these, right, by the way, theta is 45. One of these needs to get used. The cosine of 22.5, would you agree 22.5 is in the first quadrant, so that's positive. That's why I know I'm going to use that guy. If this angle here was, oh, I'm trying to think of, if this angle here was 95.5 degrees, wouldn't I say, oh, you're in the second quadrant, cosines are negative in the second quadrant, so I would have chosen negative there. So it's one takeaway, the cosine of 45 degrees, all over 2.
I thought the cosine was plus.
It is plus. Oh, you mean here? Thank you. Didn't write it down, but I knew it was. And unit circle, the cosine of 45 is root 2 over 2, all over 2. There's not really a lot you can do to make this pretty. So how about just dividing everybody and getting that? And so according to the half angle formula, the exact value for 22.5 degrees should be this. Let's see if that works. Make sure I'm in degrees. I am. Okay. The cosine of 22.5 is approximately 0.92387. Off you go. Let's find this guy now. The square root of 1/2 plus the square root of 2 divided by 4. When I hit enter, I want to see 0.923 and all the other stuff. And what went wrong? Oh, I forgot to put a blinking bracket around it. That's what went wrong. It's the square root of 2 finished divided by 4. There you go. Can you see the 0.92387? So I know it's worked. So it's a very niche market. You need to figure out who theta is first. Obviously, you're only going to pick one of these. And for 2 of them, you have to decide, is the answer positive or is it negative? Okay, let's keep that guy handy for a minute. Let's see if I can find another one. Can't see any yet, but that's because this has lots of stuff, but not really. That's a very big section. Okay, I'll just pick my own. Okay, I would like to find the exact value for the tangent of 165 degrees. And I'm going to be using that guy. What goes here? A half of what gets you 165 degrees?
$82.5.
Oh, go the other way. Instead of halving this number, go the other way. Remember what happened here? 22.5 got you 45. Right? I didn't half that to get this. Right? 22.5 got me 45. So 165 isn't going to be a small number, right? Isn't it going to be a half of a bigger number that ends up at 165? So how do you find the missing angle? What do you do then to that number?
By 2, right?
You multiply by 2. So when you get into the habit, when you do one of these questions, to double that guy. So theta is going to be 330 degrees. Now, the tangent guy, which is this formula here, says that the tangent of a half theta is the sine of theta over 1 plus the cosine of theta. In this case, it's going to be the sine of 330 degrees over 1 plus the cosine of 330 degrees. And unit circles take over. When you do the half angle for a tangent, you don't need to worry about the sign. It's included in the formula. So it might be plus or minus. We already kind of know that. If I look for the sine of 330, it's negative a half. And 1 plus the cosine of 330 is root 3 upon 2. So the exact value of the tangent of 165 degrees is this ugly guy. Any suggestions how to make this answer prettier? Style points. Fraction, fraction, really ugly. Is there anything you can do to make it nicer?
Multiply it by the reciprocal.
Okay, well, multiply by 2 then. 2 over 2. So what do we get? On the top, I get negative 1. And on the bottom, I get 2 plus root 2. Would you agree that's quite a nice answer? At least nicer than it was. And if I had time, I would check that for you, but I'm sure it works. So there's only one other combination I haven't done yet. Let's do a, here we go. Let's do a cosine of somebody. I'd like to get the exact value for the cosine of 105 degrees. Okay. We're going to use the half angle formula. What number goes here?
210.
Have you noticed you just double it every time? That's how you find theta. Double it every time. So 210 it is. Now, according to the cosine of the half angle, which is the one I'm going to use, the answer should be plus or minus this guy. In this case, we have found theta is 210. But is it a plus or is it a minus? Is the cosine of 105 positive or negative?
It's negative.
Right, it's in the second quadrant. That's how I know to use the negative. Don't I just look at which quadrant the original, right? The original means this isn't. If this is in the first, it's positive for a cosine. If this is in the second, it's that way. Now, it's going to be 1 plus the cosine of 210, all divided by 2. So it's going to be negative the square root of 1 plus the cosine of 210 is that fella. So it's negative root 3 upon 2, all divided by 2. I divide each one by 2 and I get 1/2 take away root 3 upon 4. And that would be the best version of the answer that I could get. So it's a very niche market, but essentially the half angle formula, at least the way that we use it, allows you to find the exact value of angles that are not in the unit circle. It allows us to convert them into this that does use a number that's in the unit circle, and that way we can get an exact value. Are we good? Now, if you're wondering where this kind of question would be, if I was putting that in the final, I would put that in the multiple choice. And this would be one of your answers. Well, it's quite hard. Then I have to figure out what all the other answers are. You know, maybe I'll half that angle instead of doubling it and do something like that. Or maybe I'll make it a minus and a plus, right? Make that a plus. Maybe make this a negative, you know. Permutate all the plus and minuses. That would probably be the way I would go. And then I'd look at the answers and I'd choose obviously the correct answer, and then I would figure out which ones are the wrong ones. So seem reasonable and do that.
I have a question.
Mm-hmm.
So I had the half angle formula for tangent written down.
Oh, there's two versions of it. So you had the other version?
Well, I had the 1 minus cosine x over sine x.
I'm changing them to thetas. That guy is actually him. And
Okay.
they both work. Since I got a few minutes, let's do an identity on that. Let's prove that this one is equal to that one. All right. So I'm going to take the left-hand side. And when I'm finished, it's going to look like that. Well, this one's quite a sneaky one because there's no obvious way to go here. But since I know the answer has a 1 minus cosine in it, I am going to multiply by a special version of 1 minus cosine theta. And the only reason I'm doing that is because I want a 1 minus cosine theta to be on the top. So I now have a sine theta, a 1 takeaway cosine theta, and on the bottom, I've got these two guys. I'm going to FOIL them out, and you're going to trust me in this, but you would eventually get that guy. You trust me that if you FOIL that out, you get this. Does anybody recognize what 1 minus cos squared is? What's 1 minus cos squared theta equal to?
Sine squared x or theta.
Well, yeah, whatever letter happens to be in the question. And can I now cancel this with one of those? And I am now left with isn't that kind of cool? Which one do you want? I don't care. If you use that one, you'll get the answer I got a little while ago. If you use this one, you'll get a different looking right answer. I know that seems a bit strange that you could have two answers that look different, but if you put them into the calculator, they'd be the exact same decimals. So if you actually, that last one, or the second last one that we did, if you did it using your formula, you will get the same number, right? So it works. That's kind of cool. I like the fact you noticed that. I didn't want to give you two formula because it isn't one good enough. Either one will do. You only need one. And that one's probably nicer, I guess. Not a lot of difference. Have we any more questions or we've finished for today?
I guess the last thing I have is the tangent. You don't have to choose if it's a positive or a negative like you do with the sine and cosine.
Yeah. Whatever formula you use, they both give you. So if the answer ends up being a positive number, it's positive. If the answer ends up being a negative thing, it's negative. So for the tangent of a half angle, you don't worry about the choice. Yeah, there is no need for it. Can't remember, Aidan, were you the one that asked about this?
Yes, I was.
Right. Is that enough for you?
Yeah, definitely. Thank you.
Okay. Right, then I phrased that in a weird way. Is that enough for you? But you know what I mean. Okay. Are we good for today then? I'm going to leave. I'm not going to leave. You can leave. Put your name down and say your last name and bye-bye. And I will wait in case some of you just have like a homework question or something else you want help on. Okay. So if you're good to go, I'll see you tomorrow. Bring lots of topics. Tomorrow is totally all about you. Right? Bring lots of topics, things you want to go over. Bye-bye, guys.
Thank you. Bye.
You're welcome. As I say, I'll hang about for anyone who has a specific question or whatever they want answered.
So tomorrow,
Mm-hmm.
can we go over basically? I believe it's with vectors, right? Where you're given R of theta, how to figure out what other quadrant it's in. I'd have to go look at the homework again.
Right. Well, perfect. Tomorrow you can be the first question if you remind me, and we'll do that topic first.
All right.
Right.
Sounds good. Thank you.
You're welcome. Harmon or Grace, either of you two got a question?
I was just hoping to go through some questions on test 7 that I got wrong. I think it's it's a lot of what we talked about today, like double angle formulas and all that.
Okay. I might do Harmon first if you don't mind. That way we can just focus on you after that. Harmon, do you have any questions before we move on to that? Okay, looks like Harmon just forgot to log out after he did his name, so
Yeah.
that's fine. Okay, let's move on.
The exam, Harmon, is Tuesday from 1 to 4.
Oh, is that what he was asking?
I don't know. I just put that in the chat. So. Yep.
Okay, you got it. Okay. Let's find. You said it's test 7. Grace, did you say test 7?
Yeah. Sorry, I thought I wasn't muted.
Okay. So, the score view. I want to get your questions that way. I'll use the same numbers that you've got. Okay, that goes there. And where the heck are you then? You must be under past assignments. It is test 7. Gotcha. Is it the one you got 85 for?
Yeah, it is.
Okay, then we are loading that up very slowly. Like sometime in the next hour would be nice.
Yeah.
Okay, so the first question I have that you got wrong, or if you guessed an answer and you got lucky, I can do something different. But the first one I've got is number 5. Does that sound right?
Yep.
Okay, so in question 5, you are being given the secant of x is 4/3. That's good. And you're being told that x is between 270 and 360 degrees, right? And you are being asked to find the sine of x over 2. Okay, so
yes.
So it's a half angle formula essentially. And the formula is going to be plus or minus, still to be decided. 1 take away the cosine of x over 2, because if the angle's called x, I guess my formula should be called x, right?
Yeah.
Okay. Now, what quadrant is angle x in? Where's 270 to 360?
Oh, that's the 4th quadrant.
Right. Now, if you half the angle, won't half x be somewhere between 180 and 135? What quadrant then is a half x in? So where is 135 to 180 when it's at home?
The 2nd.
And is the sign positive or negative in the 2nd quadrant?
It's positive.
So that's how I know that's a plus.
Okay, so just because the secant is 1 over sine, we're looking for where the sine is.
Yeah, I'm just interested in where the sign is. That I'll deal with later. That's not going to help me so much with this as what I just did here, right?
Yeah.
Right. Now, you tell me the secant is helpful, but actually telling me the cosine is more helpful.
Yeah.
So just because I know that, I'm not going to use that. I'm going to use the fact that the cosine is 3/4. So this becomes 1 take away 3/4 divided by 2. So this is going to be 1/4 divided by 2. which is 1/8, which is 1 over the square root of 8, which is 1 over 2 root 2. And that would have been the answer. I could have tidied up more, but that's all WebAssign was looking for.
Okay. How did we get the 3/4 again?
3/4 was if the secant of x is 4/3, then won't the cosine be 1 over it, right? The secant is the reciprocal of a cosine, but a cosine is a reciprocal of a secant, right? They're connected in that relationship. So if you tell me that's 4/3, won't the other be the reciprocal, right? Turn me upside down, in this case 3/4.
Okay, so cosine. Okay, and then you just plug that in the formula.
And then make it pretty.
Yeah, okay, here.
Now, there was another one which I want to talk about because it is, well, no, not really. I changed my mind. Basically, the other one, you do the same thing. Because if you fix this one, the other one, you would get the same answer to, right? For instance, if someone went and said to you, now, how are you going to find this guy? Won't the answer be negative? Because in the second quadrant is the cosine negative. Does that make sense?
Yeah, honestly, I'm still a little confused about that.
Right, let's just focus on that part and not do the details.
Yeah.
So suppose you know that you're being asked to find an angle X. An angle X is in the range, say 90 to 180 degrees. Right?
Okay.
Now we have 3 formula to deal with, but only 2 of them really matter. These 2, because these 2 we have to decide plus or minus, right?
Yeah.
So if X is between 90 and 180, won't a half of X be half of 90 and half of 180? And
Yeah.
I know that that guy is in the first quadrant, right? And if you're going to find the sine of this guy or the cosine of this guy, won't both of them be positives?
Yeah, because everything's positive in the first
Quadrant, right?
Okay.
So that's like one possibility, right? Okay. Now, suppose we move up the food chain and we're looking for one that's, I don't know, in the range 180 to 270, right?
Yeah.
Now, 1/2 X is going to be 135 to 90. And if I look at that, isn't that going to be in the second quadrant, that angle?
Yes.
And so if I'm using a sine, that fella, in the second quadrant, the sine is positive. But if I'm trying to find the cosine, isn't the cosine negative in the same quadrant? So that's how I decide plus or minus in that situation.
Okay.
Now, if you move up to, I guess the last permutation would be maybe something like this. Suppose you did, say, 270 to 360 degrees. Suppose X was in that range. In this case, won't a half X be between 180 and 135 degrees? And in that world, isn't that in the third quadrant?
Yeah.
Is it? I'll check that again. No, I apologize. It's still in the second quadrant, which means you're going to get the same kind of combination that I just gave you a minute ago, and you're good to go, right?
Okay.
So that's how you tell plus or minuses, right? By finding. Now, they can do that information in different ways. Couldn't they tell you X is in the second quadrant, which would be they're telling you that? Or X is in the third quadrant, they could be telling you that. Or X is in the fourth quadrant, they could be telling you that. Couldn't they give you the same range, but do it in terms of which quadrant X is in?
Yeah.
Right, but the conclusion ends up being exactly the same, right? Pluses or minuses, depending on the situation.
Okay, so because it was a little bit different with the example problems we did in class when it was just like the cosine of 105 and we knew that the answer would be negative. Because,
Right. That's because you already know the number you're trying to find, right? So if
Okay.
somebody says the cosine of 105, I know what quadrant that's in, so I know it's going to be a negative answer. If they ask me for the sine of 105, I know that's in the sine quadrant, so
Yeah.
that's a plus answer. But if you only tell me to find the sine of a half x, and the only thing you tell me is that x is somewhere, whatever it is, that it's in that range,
Mhm.
you see, I have to work a little bit harder to decide is it plus or minus.
Okay.
So that's the difference. If I know what these numbers are, pluses and minuses, I don't need to do all this half angle, what quadrant I'm in. Can't I just go up here and say, yep, 105 is in the second quadrant. The cosine of an angle in the second quadrant is negative. So I stick a negative here and I'm good to go. Sine 105, well, in the second quadrant it's positive, so positive, and off you go. And I don't care about the tan because the tan doesn't really have a plus minus choice, right? You get what you get anyway.
So this question was just adding an extra step.
Right, it was giving you the information like that, and it also gave you this weird thing, right? I've forgotten what the numbers were. 4/3, right?
Mm-hmm.
But I mean, the next time, couldn't they just tell you, what could they tell you? Well, they're not really an awful lot they could tell you. They could just tell you it was 3/4. That would be nice of them, wouldn't it?
Yeah, it would have been.
But I mean, if they had told you it was a half,
Mm-hmm.
couldn't you have built a right angle triangle out of that and figured out that the cosine was 2/√5?
Yeah.
So, I mean, they could have made it harder by telling you one of the other 6 trig ratios, and then you could just figure out what the cosine was. Because the half angle formula, or at least these two at least, don't they use the cosine?
Yes.
And this one also uses the sine. So you might have to use a little right angle triangle. If it was this one, for instance, wouldn't the sine of x be 1/√5?
Mm-hmm. Yeah. Okay.
Anything else? Or you good? Oh, we're still on the test. I should sketch. Let's see what the next one you had trouble with. The next one you had trouble with was 9 and then 11. So let's click on 9.
Okay.
9. What did you do with 9?
I couldn't tell you. This lesson, reviewing today, really helps because I was lost this week.
Okay. Right, so on question 9, they've given you the equation already factored. That was very nice of them. At least partially factored, I guess would be a better way of saying it. And we're basically being asked to find the answers to comma separated list using one of those K things. And off we go. So the tan of theta minus 4 equals 0. So that tells me the tangent of theta is 4. And since this question is going to have decimals, I'll make sure I'm in radians, which I'm not. And now I'm in radians. And I will find the missing angle by finding the inverse tan of 4. So here goes. It's the inverse tan of 4, which is 1 point, how many decimal places? 326. They want 3 decimal places. Right. Now, what is the period of tan theta?
Is it? Oh goodness.
Oh, we did 2 thetas and 3 thetas today. This is the easier one. What's just a tan and 1 theta?
It's pi, right?
It's pi. So there is a bunch of right answers, right? Just
Okay.
add k times the period, okay?
Mm-hmm.
Now, when you do a tangent and you look at the answer that we've just got, there are two places where the answer could lie. But the good thing about the tangent is if I did all the other answers, they just end up being this guy again. Remember, we did two piles and this pile ended up being here. So we're finished with the tans. A lot more work on the sines.
When I'm taking the inverse tangent of 4, I'm getting 75.
Ah, that's because you are in degrees, not radians.
Okay. Okay. There we are. And why do we want to be in radians as opposed to?
Only because the question had radians in all of them.
Oh, okay.
Every question, at least, yeah. Does it say physically radians? It doesn't, but it wants them. Yeah. I mean, if I wanted to do it the way you just said, it would be what, 75 point whatever degrees plus 180 pi. Wouldn't that be the equivalent answer in degrees?
Yes. Mm-hmm.
I don't know what it says. Like say it's 75.123, but that would be it. And that wouldn't be a pi, that would be a k. There. Right, let's focus on this guy.
Okay.
Then 9 sine squared theta has to be 1. So sine squared theta has to be 1/9. And if you take the square root of both sides, sine theta is 1/3. And sine theta could also be -1/3.
Oh, it's equal to plus or yeah. Okay.
Right. Now, if you go, again, I'm staying on radians. So if you do the inverse sine of 1/3, you will get the answer 0.3398, God, 0.34 then, right? If you round that off, but I'm not going to do it now, too late. Plus 2 pi k, because the period of a sine function is 2 pi, right?
Yes.
Now, if you do an inverse sine of -1/3, you'll get -0.339 plus 2 pi k.
Okay.
Now, the only problem with this question, it's not really a problem, is you know that when you get negative answers, we really don't want negative answers, don't we? Want the 0 to 2 pi answer.
Yeah.
So I would add 2 pi to that just to make it a nice number. And so I would change that guy. Me personally, I would have changed that into 5.943 plus 2 pi k.